Moving on to example 3. Here we're going to find the integral of 1 over the square root of 4 minus x squared dx. From example 1, we know that this is going to involve the substitution of 2 sine u equals to x. Okay, so let's put u here. And what have we got here? I have x over 2, making the adjacent side 4 minus x squared square root. Okay. Then now we can differentiate 2 cos u du equals to dx. And I know that this cosine or adjacent side here is 2 cos u. Let's apply that to the integral. So dx is 2 cos u du, and now the denominator can be written as 2 cosine u. All right. It's all of that can be simplified nicely. And I'm just taking the integral of 1 du. This gives u plus c. What is u in this case? Well, if we go back to the first line, that can give us a useful substitution here. Because if I do that, I know I get sine u equals to x over 2, or u is the arc sine, right, of x over 2. And here we are, arc sine x over 2 plus c. Using this particular example, can you figure out a formula that is useful to find the integral of 1 over square root of a squared minus x squared dx? We just need to do some matching here, right? Because what we got was arc sine x over, well, it was 2 from part 1. So in general, it's going to be a plus c. This is found in your formula booklet. Okay. Part B. How about this particular question? Integrate 1 over the square root of 4 minus 9x squared dx. Once again, the format here is number minus a term involving x squared. The same substitution will apply. Let number 2 sine u equal to so-called x. But in this case, this is going to be 3x. Okay. So let's label my diagram to help me visualize this. So opposite 3x over hypotenuse is 2. This is 4 minus 9x squared, making this is 2 cos u. Okay. The derivative of a let statement becomes 2 cos u du equals 3dx, which means that when I do the substitution, dx is 2 over 3 cos u du, and the denominator is 2 cos u. This is still going to be something easy to work with. I am going to be taking the integral of 1/3 du really, which gives me 1 over 3 u plus c. Expressing u in terms of x, once again, I'm going to make use of my original let statement. I know that sine u is 3x over 2. As a result, u is arc sine 3x over 2. So let's sub this back. arc sine 3x over 2 plus c. Okay. So now we just have to make some adjustments to that general formula that we have stated earlier. Let's try to match up part 2 to part 1 here. We notice that this integral becomes 1 over b arc sine bx over a plus c. So this is a more general form of this particular trig substitution for arcsine. Using the experience that you had in example 3, let's look at example 4. Determine a formula to find the integral of 1 over a squared plus bx squared dx. When you have the addition of the two so-called square term, you may recall that this is related to a substitution for a tan u. Okay? Alright, so let's pull out my red pen. I will let a tan u to be bx in this case. So if this is u, bx is opposite, a is adjacent, this is a squared plus bx squared, square root. Okay. Which gives me a secant square u equals du, equals to b dx. And then the substitution that I will need would be for the square root of a squared plus bx squared, and this would be a times secant u. Alright, so here we have 1 over a squared plus bx squared dx. Now substituting, I will have a over b secant square u du for dx, and the denominator is a secant u squared. Okay? What does this mean? This means I'm integrating a over b over a squared, which is 1 over ab, times secant square u over secant square u, which is 1 du. This is 1 over ab, u plus c. What is u? U now is tan u equals bx over a, or u is arctan of bx over a. So here, 1 over ab arctan bx over a plus c. Okay? Your formula booklet shows a simpler version, like without that coefficient b in front of x, basically. And let me write down its version here. So formula booklet gives you the integral of a squared plus x squared dx equals to 1 over a arc tan x over a plus c. All right. Here is example 5. We have a definite integral 1 over x squared minus 2x plus 5 dx from 3 to 1 plus 2 root 3. Let's start with the indefinite integral. It's a quadratic. Substitution does not work. It doesn't look like any of these three formats of like a squared minus x, a squared plus x squared, all of these trig substitution format that we have talked about so far. So why is this in this lesson? Well, if you consider rewriting the form of that quadratic expression, then you will actually end up with, an a squared plus x squared format in this case. And that procedure is called completing the square. Okay, so I'm going to separate that definite integral business later. Okay, so let's just deal with this part. It's exciting. Okay, let's complete the square. I have 1 over x squared minus 2x. Well, that means I should have the perfect square of x minus 1 squared, because that will give me x squared minus 2x plus 1. Minus 1 plus 5 is plus 4. There we go. So now we can pull out the famous diagram, the right triangle. Okay. Since we have the addition of the two majiggy thingy, I'm going to do 2 tan u equals x minus 1. So u, x minus 1 is opposite, adjacent. Okay. The derivative of this guy is 2 secant square u du equals dx still. Not that. Oh, I forgot something. I noticed here. Okay. And then the substitution that I need to make would be for x minus 1 squared plus 4, which really is the hypotenuse part here. This is star, star, okay? And this can be written as 2 secant u. All right, let's sub. Here I have, in place of dx, 2 secant square u du. In place of my original denominator, I have 4 secant squared u. That's good, because then I have 1 over 2 integral of just du, which is u plus c. And then using the first line here, tan u would be x minus 1 over 2, which means that u is arc tan x minus 1 over 2 plus c. This result will allow us to evaluate the actual definite integral. Okay, so the definite integral is 1 plus 2 or 3 here, x squared minus 2x plus 5 dx. But we already found that this is the same as 1 over arc tan of x minus 1 over 2, 3 here, 1 plus 2 over 3 here. Okay. This gives me, I'm going to let 1/2 sit outside. This is arc tan of 1 plus 2 over 3 minus 1, which is 2 over 3 over 2, which is root 3. Okay. Minus arc tan of 3 minus 1 is 2 over 2, which is 1. Okay. Put brackets here. So arctangent of root 3, you can use this triangle, right? 2, 1, root 3. And root 3 over 1, opposite is the angle pi over 3. And then arctan of 1, you should know it is pi over 4. So I have 4 pi over 12 minus 3 pi over 12, 1 pi over 12. Half of that is 1 pi over 24. Done. All right. So you might be wondering, well, if there are formulas in the formula booklet, can we not use it? Well, let's try that, right? We have some room here. In this particular question, we still have to first write your integral in terms of 1 over x minus 1 squared plus 4. And then according to the formula, if you go back up a little bit, right, when we see that formula here, it says the integral of 1 over a squared plus x squared is 1 over a arctan x over a plus c. So here we can pretend in this expression, let me rewrite it, squared. Okay, so if we write it out like that, taking the place of a squared is 4. And taking the place of x squared, the variable is x minus 1 squared. So here, this will become 1 over square root of 4, 2. Arc tan, your so-called x over 2. Does that match with what we have down here? Yep.